Good day. Today we're going to be expanding and condensing logarithms. As a warm-up today, we're going to convert the following functions. So the first one is going to be 27 is equal to 3 to the third. 6 is equal to 36 to the half power, or square root of 36. 1/2 is equal to log base 4 of 2. And then lastly, -3 is equal to log base 3, 1 over 27. Okay. There's your warm-up finished. Let's move on to properties of logarithms. Now, there are several properties here that you have to know, but we're not going to use all of these all the time. The biggest ones you have to know this one, log of 1. You have to know the product quotient power rules. You have to know the equality rule. Now, sometimes we'll have the number raised to a log rule, but that one will be viewed less often than the other ones in pink. You need to know them all, but you need to really understand those ones that I put a tick mark by. Log of 1, any base of log, if it's to the 1, it is equal to 0. If you have the log of the same base, it is equal to 1. That should make sense. So if I had log base 6 of 6, how many times can I multiply by 6 to get 6? 1 time. First one is 6, is equal, so it's 1. That should make sense to you. The product rule. If I have a log of a base, and inside the parentheses have two numbers being multiplied together, I can separate those out into the log of the base to the m, and then plus log to the base of n. If it's dividing on the inside, instead of plus, you do minus. That's the quotient rule. Now that is expanding. Condensing, you can work in reverse order, so it's log base a of m plus log base a of n. It can just be log base a of m times n. So it works in either direction. The power rule. If I have log base a of m and I have an exponent on top, I can take the exponent, move it in front of my log by multiplication. Okay? Change of base. Log base b of a is equal to log base c of a, log base c of b. That c is the same. So normally what I'm going to do if I do this, I'm going to just put log, which is understood to be the invisible base 10 there. So log of a over log of b. That's how I would do it. But you can put any base that you want. I don't really know why you would put a base if you're changing the base to get rid of it. Anyway, equality rule. If I have log of a base of a equals log of the same base of c, then I know that the log of the b's bases cancel out, so a equals c. That's all that says. Number raised to a log. If I have a, well, let's just use a number. If I have 7 raised to the power of log base 7 of 52, these cancel, and I just have 52. There's that rule. There's the other rules. If you want them, you can read them. Personally, I don't really care about them because you're not going to use them. All right. I have underlined the problems I'm going to do. I want you to pause the video and try the ones that are not underlined. So expand the following problems. Number 2 is log base 3 of 4 times x times y. This is log base 3 of 4 plus log, do not forget the base 3's, base 3 of x plus log base 3 of y. Okay, number 4. This one is ln, so natural log. I have the natural log of 4, so I'm doing the numerators, plus natural log of x. Now that's the numerator taken care of. For this problem, there is only one thing in the denominator. You have two options though. You can either put minus and then parenthesis everything on bottom, or for every term in the denominator, just put another minus. But minus natural log of y to the second power. Now this is not finished because I have a log raised to a power. So I'm going to rewrite the first part, ln 4 plus ln x minus, all right, the 2 is going to come out front, 2 times the natural log of y, finished. Now there's a reason I left the parentheses off the top expression. If I put parentheses here, I can pull out, so more or less reverse the power rule, the exponent raised to a power rule, and I can pull out the 2, but there's only one term, so I can just rewrite it like that also. Okay? Be familiar with how to work exponents. They are very important in these problems. Condense the following. I'm going to work number 7, and then I'm going to show you 2 in mixed practice. I think it's 2, it might be 3. I'm not sure. All right, number 7. Log of x to the 20 plus 1/3 log base x of 27. First thing I want to verify, it has the same base. That is good. I can work with this. First things first, I'm going to move this power rule up onto the top. So this is log of base x of 20 plus log base x. All right, to the 1/3 power is the same thing as the cubic root of 27. Now the reason why I wrote it that way, this is log base x of 20 plus log base x of 3. Now I'm going to combine these. This is log base x of 20 times 3. I'm going to perform a little bit of arithmetic to simplify the inside of this logarithm. Log base x, 20 times 3 is 60, and I'm finished. Now, I have been choosing the harder ones out of the problems, so if you understand this one, you should have no problem with any of the ones above. Okay, let's do 8 and 9. Number 8. I have log base 4 of that entire string of symbols and numbers. So I have log base 4 of 5 plus, now I'm going to go in and rewrite, well, I'll do it 2 separate lines. Log base 4 of x to the 3rd plus log base 4 of y to the 5th plus log base 4 of z. Now remember exponent rules. If I have a nth power, it's just the number on the denominator. So this is log base 4 of z to the 2/3, to the 2/3 power. All right, I'm going to use the power rule of logarithms. Log base 4 of 5 plus log base 3 log. Okay, let me rewrite that. 3 log base 4 of x plus 5 log base 4 of y. Now you could put plus 2/3, but I'm going to do plus 2 log base 4 of z, all divided by 3. The reason why I'm writing it like that is to show you a different representation that you might see in the future. Okay, last one. Remember how I said before, whenever I was expanding the logarithm, I had a denominator. This one has minus parentheses, so you can either do it the way I'm about to, or you could distribute this negative to both things and have negative log base 3x plus 4 minus 4 log base 3 of w. You could do that. I'm not going to. What I'm going to do is first move the 3 on the first term up into that y, and then I'm going to combine with multiplication. So log base 3 of 4 times y cubed. I hope you're okay with that one. Minus, I'm going to combine the right set of parentheses now. So I am going to move the 4 up into the w, and I'm going to put log base 3 of x times w to the 4th. Now I'm just going to combine these two. This is subtraction for the quotient rule. Log base 3 I'm going to have 4y cubed on the numerator and xw to the 4th in the denominator. Finished. Try 10 and 11. So I'm going to go up one more time, give you the opportunity to pause the video to try numbers 1 and 3, 5 and 6, 10 and 11. All right, now let's go to the answers. This is all I have for you today. I hope you have a great rest of your day.